Okay. Well, I've just gone ahead and I've started another stream because the last one I couldn't see any of the chat on it, and I certainly didn't have an option to do anything like restart the stream or get it going again or even refresh the page. So I'm just going to leave it a minute to see if. All right, okay. Thanks, Mac Vision. I can see somebody's joined. So thanks for joining and coming over to the other screen. I'll just give it a moment to for a few other people to find us, and then we will get going. I have actually got a little bit of cleaning to do because we've got this this bush radio that we was looking at last time, and it's in a terrible state. So just while a few people join, I think I'm just going to do a little bit of a dusting because we have 70 years worth of Jack Russell hair and dead skin off some old man piled up inside this radio. So we're just going to give it a bit of a brush into the bin because it's in a really horrible condition. It's absolutely filthy. And every time I touch it, more and more dust falls off. Okay, that's probably got the worst of it off. Take two, very much. Right, okay, well, hello everybody, and thanks for bearing with me. Just to let you know, we're having some technical problems there. I'll let you know what I did. I did start the stream. I couldn't see any of your comments at all. So what I did then was I just tried to refresh the page, and when I tried to refresh the page, I got a message from Graham to say that the stream had died. Now I can't see anything on my screen at the moment. I just use was it YouTube Creators Studio to run these streams. I'm not using any specialist software. I'm just clicking on the go live button. But when the stream dies, there doesn't seem to be any buttons that you can do. There doesn't seem to be any buttons that you can press to restart that stream. It just seems that the only thing you can do is create another stream and go again. So I'm sorry about that, and thanks for bearing with me. Thanks for joining us, Scott. I dread to think what time it is in the morning. So we've got DefPom with us. So I'm sure you all know Scott the DefPom. If you haven't subscribed to his channel, you could go away and do that. I'm sure you'll find more interesting contents on Scott's channel than you will here. It must be very early in the morning over where you are. I guess in New Zealand. If I were you, I'd get yourself off to bed because you're not missing anything. So who have we got in the room today? Let's give some shout outs to everybody. Oh, it's 1 a.m. Go to bed, mate, and maybe I'll catch up. If you do a stream later, we can catch up. You seem to do them at a better time than I do. So we've got Mac Vision, hello. We've got DefPom, hello. We've got Benji, the happy little fox, hello Benji. We've got Bretsky, take two. Yeah, we've got Ben Humphries. Hello, Ben. We've got Graham, Radio Cruncher. We've got Petronics, Nick. Hello, Nick. We've got Michael, Bretsky. So we've got a pretty full house. Oh, and Calibrator. You want to do some valve radio, Scott. That's where you're going wrong. You want to quit those calibrators. Far too complicated and finicky. Just get some valve radios. They're very difficult to destroy in my experience. So last week we were messing with this. Oh, hello, Doug. So last week we were messing with this Bush BP90, which, well, I'm not a massive fan of these types of radios because they're a battery set. I actually bought it by mistake on eBay as usual. I was probably terribly drunk and it was late at night. Hello, Paul. It was probably late at night. I was probably terribly drunk and I probably got a bit click happy. It was probably fairly cheap. I don't tend to pay a lot for valve radios. My limit is about 20 or 30 pounds. So I tend not to spend a lot of money on valve radios. So I'm sure the reason I got this is because it probably fitted my budget. And then when I realized it was a battery set, because I always do the research after I bought them. I'm not sensible and I don't do the research first and look into it. I just impulse buy. I'm afraid that's my weakness. So I got the set home and undid. I took the cover off the back and found out there was a big hole where the battery should go. Where is the cover? I think we've got the cover in the other room. So what we did last week is we got the radio out. We made the alarming discovery that it was a battery set. Hello, Keith. Average Joe. Hello, Sam. So we made this wretched discovery. It's a battery set. And of course, battery sets are just generally wretched in that, of course, they require batteries or one of those battery eliminators, which I don't have. But luckily, I do have some high voltage power supplies that we can use for testing. So we had the radio on the bench last week, and we discovered something which was a first for me. So I've been restoring valve radios now. I don't claim to be an expert, but I've probably been doing it about, I don't know, just over 10 years, maybe 15 years. And in that time, I've probably restored maybe 20 or 30 sets. So we're not talking hundreds. But out of all those valve radios, I don't think I'd ever bought a valve radio that had a bad valve in it. I've certainly bought valve radios where they've been delivered and the valves has been smashed. But assuming that the valves have actually got to me, you know, the radio's got to me and it's intact, I've generally found that with a little bit of work, you know, you put some power onto the radio and it generally powers up. Valve radios are not difficult to repair. They are the low-hanging fruit of the electronics world. So it was a real surprise that when we actually looked at this set that the actual filaments, because of course these are fermionic valves, they have heaters inside them. You need to put a little bit of heat up the backsides of the electrons, otherwise they'll quite happily sit on the cathode. So you need to heat up the cathode, which encourages them to jump off and start the journey towards the anode. So for whatever reason, the filament valves, these are a battery set, sorry, and the filaments are all connected in parallel. And there is 1, 2, 3, 4 valves in this particular radio. And all but one of the valves was open circuit. So I actually think that, you know, I've actually put a cross on all these valves. And well, that's a first for me. I've never had a valve radio that had so many bad valves in it. I can only assume that maybe because it's a battery set, somebody was messing with it, trying to get it powered up. Maybe they thought that the filament supply to this was 6 volts, which is, you know, 6.3 volts, which is a very common voltage for radios. Maybe they applied 6.3 volts to it as opposed to 1.5 volts. So these are only 1.5 volts because these are actually designed to work in this case from a 1.5 volt dry battery. And I suppose we should mention the HT. So the battery that these type of radios use have got 2 cells in them. They've got more than 2 cells, but they've got a 1.5 volt cell which actually supplies the heaters to the valves. And then because again it's valves, you need a high tension supply, high voltage, which is 90 volts. So the original batteries that would have been in this radio, it would have had a 1.5 volt battery and a 90 volt battery, and both those batteries would have been contained in the same package. So all I can assume is that somebody was maybe playing around trying to get this radio powered up, and they burnt out the heaters. And yeah, okay, I'm not going to blame somebody for that. That happens. So I went on eBay last week and I purchased, unfortunately, they're not new valves. I've actually purchased some second-hand valves, but I haven't tried them yet. Let me just see if I can maybe angle my camera down a little bit. Hello, Colin. Thanks for joining us there. Oh, and hello, Victor. Yeah, we've got a fairly full house today. Don't hesitate to chat amongst yourselves. You don't have to sit and listen to me. I'm sure you've got more interesting things to talk about, but I'll just waffle on regardless. So I went ahead and I purchased some valves. The average price of these valves, they range from about, I think it was about £5.50 to about £7.50. So this radio I think I paid about £20 for the radio, and I probably now paid for about £25 worth of valves for it. So, you know, this radio probably owes me about 50 quid at the moment. That's the sort of money we've got invested in it. So we've gone ahead and we've bought some valves. So let's see what we've got here. Okay, so we've got a DF33 here, and the DF33 valve, that's actually it's an RF amplifier valve, a DF33. It's actually used as an intermediate frequency amplifier in this receiver. Now, an interesting thing about the DF33 is it's a variable mu valve. Now, the thing about a variable mu valve, they kind of have an inverse logarithmic output. So the higher the signal level you put into a variable mu valve, the lower the output will be. Well, not the lower. It's just that maybe I didn't explain that very well. It's not the output. The gain of the valve is logarithmic, so it amplifies very low signals. It has more gain for low power signals than it does for high power signals. So really, the variable mu valves were actually invented for TRF sets, which would suffer terribly with problems of overloading. So I don't know, it does seem a little bit interesting to me that they put a variable mu valve as the IF amplifier. So that's a DF33 anyway, so that's one of our valves. And that looks in, looks in good condition. It's got a couple of little scratches on the metallizing on the envelope. So these are kind of metallized screen valves, which is usually used to control the capacitance of the valve. It's not really used to do a lot of screening as such. It's used to provide a fixed capacitive loading to the internal electrodes, so that things moving around it don't actually affect the tuning and stuff like that. So there's a metallized valve. We'll put that back into its box before I drop it on the floor. Okay, well, the second valve is one that I took out of the radio earlier, which is a 1H5GT, which is just an audio output valve, so nothing very special about that. Benji's just getting up for a brew. Can I have one? Tea, no sugar, milk? Okay, so the next valve is a DK32. Okay, so our DK32, this is our frequency changer, and so it's got a couple of like separate valves in here, and it's what they call an electron coupled valve. So one of the sections of the valves is coupled to the next section using electron flow rather than physical wiring. So yeah, it's an electron coupled tube, DK32, and this is our frequency changer. Is that a heptode? I think it might be a heptode. I'm not dead sure. Somebody can leave it in the comments who knows more than me. Oh, I just noticed that somebody's actually scribbled on the side of this valve, weak. What do you think about that? So I purchased this as a good tested valve, and it's got scraped into the side of it the word weak. Well, I guess buyer beware. I think we're going to have to test some of these valves. I was just going to stick these valves in, but now we've actually seen that somebody's written on the side of it weak. Well, I suspect whether that's any good or not. What a swizz. Got a good mind to go on my eBay page, find out who I purchased that off, and put a warning out. I suppose we'll better test it first before we shame the person. And my final valve here is a DL35. So I think a DL35, I think that's a combined triode and diode. So the purpose of this valve is it rectifies, it recovers the audio from the IF frequency. So this is our detector valve, if you like. So there we go. So we've got 4 valves in total. And what I think we'll do is, because this one is, I was just going to put these in and give it a try, but yeah, I think we should go ahead and test these. Does anyone see a valve tester? I think I've got my Senko valve tester to hand. Should we test some valves? Should we give that a go? What do you think? Just catch up on the chat. Were the valves burnt out? Yeah. Yeah, Brett, all of the valve filaments were open circuit. Every one of them was burnt out. So I can only assume that they had too much voltage up them, because they don't like it up them. Oh, Vintage Electronic Repair. Hello, Handy, and thanks for the plug that you gave me on my channel. And just for the record, no, I am not from Barnsley. I'm not a tight Yorkshireman. I'm actually from fairly close to you, from Ashton-under-Lyne, which is another scrubber's paradise. So yes, I am in fact from Ashton-under-Lyne, but not Stockport, but I know where you are. Who else have we got? Black tea. Oh, Benji's drinking black tea. We don't want black tea, no. AKA Russian prison tea. Well, if that's what you like. Oh, Scott's saying, the closest thing I've got to doing valve stuff is when I bought a heat kit. Oh, okay. An IT12 signal tracer, but it worked. Yeah, I think I've got an IT12 heat kit signal tracer. They're very handy, aren't they? Well, I know you do, or you used to do, a lot with CBs. I don't know if, again, I'm sure most of you know Scott, the Deaf Pom. He used to run probably one of the biggest sites on the internet, which was devoted to CB and CB information and schematics. And I'm sure if Scott wants to, you can put a link up to that in the chat. But I think you still run that CB site. And the other thing that I know that Scott used to be into was car audio gear, I believe. I think that's how he got his name, the Deaf Pom, because he used to get these cars in New Zealand. I think he's originally a Brit, but when he moved to New Zealand, he used to put these big speakers and amplifiers in cars. So I guess that's why they called him the Deaf Pom. So I think that was the story anyway. I'm sure he'll correct me if I'm wrong. Oh, we're going to play Valve Bingo. Okay, yeah, we can play Valve Bingo. Average Joe says, okay, Average Joe's. Yes, get the valve tester out. Okay, I think the DL35 is the audio output valve. What did I say it was? Did I say it was a frequency changer valve? Let me just have a look at I have got the diagram here. No, the DK32 is a frequency changer, and sorry, it's a DL35 is I think is the output valve. Maybe did I say something wrong? Maybe. Going from memory here. All right, okay. Scott says his site's still going. Yep. So if you need to know anything about CB radios, that is Scott's site is the one to go to. I certainly think I've been to it in the past. I'm fairly sure Scott very kindly sent me a little cheat link to it where I could download schematics. So that was good of him. Okay, let's get the valve tester out. I was going to put the lid down, but I've just realised we need the lid because it's got the data book inside it that's going to tell us what all these valves are. Okay, just zeroing the valve tester there for my mains voltage. So this, I've actually got quite a few valve testers. Can I focus that in a little bit better? Yeah, I think that's a bit better for you, isn't it? So this is my Senko, and it's a Mighty Mite valve tester, a TC154. It's actually a kind of, there's lots of different types of valve testers. I think one of the other types is like the mutual conductance testers. In fact, I could actually show you a mutual conductance tester if you're interested. Let me show you a mutual conductance tester. So this valve tester, which I'm not going to be using today because I've noticed that it's actually, I'm having trouble with the mains setting on it with the voltage calibration. So it's actually in here with the idea of me doing some repairs on it when I get round to it. So this thing is an AVO tester. And as you can probably see, it's, I would call it a thing of beauty. So this one will actually do what they call characterizing valves. It will actually profile the gain of the valve, and it'll test an awful lot more than the Senko tester. So you can think of the Senko tester. If this was engineering, I would call it a go no go gauge. That's what a Senko tester is. It'll tell you if something is the right size or not. Whereas something like this, which is a mutual conductance tester, this is a measuring. This is an actual measuring instrument, a measuring instrument. So this is more like a micrometer, whereas the Senko tester here is just a go no go gauge. So what you would use this type of tester for is if you're one of these audio people where you've got, I don't know, these amplifiers that use push-pull stages. You want to minimize the crossover distortion by having matched output pairs in an amplifier. So you need to be able to characterize the gain profile of the valve to make sure that the two valves are pushing the pushing valve to make sure that they match. So you could use this type of tester to do that matching. So as I say, this is an AVO one. It's a CT160. And you pretty much got to, sell both your kidneys to actually get one of these days. I actually think that valve testers are one of those things which is massively overpriced. These things can cost you anything between, I'm going to say anything between 500 and probably more than £1,000 up to 1,500 for a working one now. I didn't pay that. In fact, I didn't pay anything for this. I was very lucky somebody gave it to me. But valve testers are a piece of equipment that you can just pay absolutely silly money for. And again, I've been working on valve radios for many years, and a valve tester is a piece of equipment which I use infrequently. I suspect I use a valve tester about once a year. So if ever you're thinking about should I buy a valve tester? My kind of advice to you is don't buy a valve tester, because Simon, my kind of advice to you is don't buy a valve tester because valves are still relatively cheap. About the only time you'll ever use a valve tester is like today, where I've got a few valves on the bench. I'm not exactly sure about the provenance of them, and I want to have a quick look to see if they're any good or not. But having said that, the best valve tester that you can get is a radio receiver. So if you put a valve into a radio receiver and it doesn't work, that's a valve tester. It will tell you that valve doesn't work. But so a valve tester isn't something I would suggest you go out and buy. If you drop on a valve tester for the right price, of course, go ahead and do that, but don't spend too much money. So this is a Senko tester. I think I bought this one. I bought this one earlier in the year. It might have been the end of last year. And again, this wasn't a particularly cheap instrument. It was about £350, I seem to think, and that is about the going rate for these, around £350. The reason that I've just told you not to buy valve testers, well, the reason that I bought it is because I like collecting test gear. That's one of my things. Test instruments and test gear is kind of one of my interests. Although I've not got it quite as bad as Scott with all his. Do you call it metallurgy? What is that metalwork? Metrology, isn't it? He's got all these very accurate voltmeters. I'm generally happy if my voltmeter measures to a volt here or there. The volt's quite good enough for me, but Scott has got these voltmeters that measure to about 12 decimal places, so that's a lot more accuracy than I need. Let me just catch up with the chat. So I saw that Simon snuck into the room. Hi, Simon. Oh, driver films shortwave. That's an unusual title. Why did you get that name, driver films shortwave? I always meant to ask you that. Why do you call yourself that? I'm trying to work out where that comes from. We got to take my hay fever tablets today. Oh dear. Yeah, Doug's just said there that there's lots of times where a valve will test good on a valve tester, and it won't test good. And when you put it in a radio set, it won't work. And yeah, Doug's quite right. So yeah, so I bought this valve tester because it was just another gadget, and you know, I got that itch, and I needed to buy some more test gear. So that's the reason that I bought it. So we're going to have to test these valves now. The thing about valve testers is they have to be set up for all the different types of valves that you are using, and the way that you set them up is you need to use a data book. So again, if you do buy a valve tester, it's important that you make sure that it has the data book with it. And if it doesn't have the data book, make sure that you can at least you can download it from somewhere, because there is valve testers out there where, in fact, I've got one of them. I forget what model it is, but oh, it's a Hickok one. I've got a Hickok valve tester where the manual actually isn't particularly available. It's the one that is available is a different model. And when you use the setup data in the manual, you get slightly misleading readings. Again, it tends to read a bit high. So when you buy a valve tester, it's important to make sure it either comes with the data book, or to make sure that you can actually download the data book from somewhere. Most of the data books, especially for the Sencor stuff, you can get them online from lots of places. You don't have to pay for them. But make sure it comes with a data book, or you're going to be stuck. And probably the other good thing that you need to do is make sure that it'll do the range of valves that you want to work on, because obviously if you buy a very, very old valve tester, it might not have some of the more modern valves in it in the data book. Or if you buy a more modern valve tester, it might not test valves from the 1930s and stuff like that. In fact, I can see this the CT160 has got valve sockets on there that this one hasn't got. So certainly the Avo CT160 will test a lot more valves than this Sencor will. So we're going to be testing an octal valve, which is these sockets here. I actually learned something last week in the chat, in that you know, I wasn't sure what the difference was between octal and loctal, and I don't know. I think it was, I can't remember if it was Paul or it was Simon, but in one of the messenger groups that I'm a member of, I think maybe it was Paul, he put up a data sheet explaining the difference between octal and loctal. So these types of valves here that we're looking at today, these are octal valves, in that they've got a 10, 12, I think they've got 8 pins on them, haven't they? That's why they're called octal. And they've got a peg, which is used for an alignment, and the peg has got a little pin on it, a bit like a DIN connector. You probably can't see it on the camera, but it has got like a rib. It's ribbed for her pleasure down one side, so that you can only put these in one direction. You know, they're actually keyed, so you can only put them in one way around. But if you actually to hang these upside down, the valve could still wriggle out. So there's another type of valve which looks very similar to this. It's got a similar pin arrangement, but they call it loctal, and it has like almost has like a little knob, a little pip on the end of it. And the little pip is kind of like a bayonet, so that it pushes into the socket, and then the socket grabs hold of the pip on the end of the valve. It goes around the little ball on the end. So you used to use loctal type valves in stuff like automotive or equipment on ships or aeroplanes, where you get a lot of vibration and stuff moving around, where the valve could work out of its socket and drop out. That's where you would use these loctal valves, but these are octal. Oh, talking that much rubbish today, I'm thirsty. So I think the one we'll test first is this one that has the word weak scribbled into it. I'm absolutely gutted. Can you see that? I don't think... Oh no, I need to, let me improve it for you, because I want you to get as angry as I am about this. There we go, weak. That's what it's got scraped into the side of it. So somebody has sold me a valve, and on the website where I bought these valves from, I bought them from two different companies, and I don't want to identify the seller wrongly, but both companies said that the valves had been tested 100% on valve testers, or they tested strongly anyway. So we'll find out. So this one is a DK32. So I think the English section, it's got American valves, because these are American Senko. Okay, DK32. So it's telling me we need to use socket 1, which is that socket, which it doesn't seem to want to go in. Let me lie it down. Wow, that is very tight. I don't want to break anything. Let's put a bit of deoxit on it to lube it up. Probably the valve tester. This socket has probably never been used. Okay, that's got it. That went in. So socket 1, DK32, and then it's got a number of settings which correspond to in the book here. So I've got to look at the valve information, DK32. Now it's saying that knob A needs to be set to 1. So that's minimum 1. Socket B has to be set to G, which it is. Socket C has to be set to 6, which it is. Socket D has to be set to E, which it is now. Socket 1. Now, because this is a top cap valve, and I've never used this tester with the top cap, but I'm guessing it is a top cap valve, so I'm assuming we have to put the top cap connection on it. That's my assumption anyway. Let me just catch up. Somebody might be telling me I'm doing this horribly wrong. Let me just make sure. Driver film shortwave. So he was saying that the channel was meant to be about driving on the road and videoing it. I'm like, that was his old channel. Okay, yeah, you have to give us a link to that. Benji's saying that he's had transistors that would work in one radio that wouldn't work in another. Yeah, I've had strange things like that as well. And Paul's just telling us, Cody's the advantage of the different types of octal and loctal tubes. Okay, right, in theory now, all we've got to do is press these switches in order, in that you start off by looking for short circuits. If there's a short circuit within the valve here, there's a little lamp that will light up with the it says short next to it. So I press that, and as soon as you switch it on, it just flash up briefly, and then the light goes out again. So it's not showing for shorts. Then we press the grid leak button. I'm wondering, can I get this so you're not getting any reflection? Okay, I think you can just about see that, can't you? So I've got no shorts. Let's try grid leak. It's coming up in the good section for grid leakage, and now the final one is emission test. So we'll press the button. Okay, and the emission is actually coming up in the goods section. Now, what I would generally do with this is I would, if this was another type of valve, I would now turn the filament down a little bit, the filament heater, because the amount of emission given off by a valve is somewhat proportional to the heater. So a good way to make sure that your valve tester is providing, an intelligent reading, what you should actually do is you turn the filament voltage down a couple of clicks, and you'll find that the emission should drop off a bit. It's just a telltale, I think that's probably the word you call it, it's just a telltale that your valve tester is actually working, because if you drop the filament voltage, the emission will fall slightly. But unfortunately, 1 volt is absolutely the lowest emission that I can use for this. And you probably can't see it because the needle is very fine, but the needle has come over into the goods section. So we'll switch off. Actually, I just wonder if it does use that top cap. I'm just going to try that again with the top cap remove. I'm not sure what the top cap electrode is on that valve. Okay, still comes up good. Do we trust it? Don't know whether to trust it or not, to be quite honest, but it's all we've got. See, that's the other thing about having valve testers. I mean, do you trust the valve tester? Because valve testers need calibrating as well, and they are often not the easiest thing to calibrate. You kind of need valves which have got known emissions from them. You need a known valve which has been characterized. And although you can buy those valves from America, there's people who will characterize valves for you. And in fact, you can do it yourself if you're prepared to put a bit of work into it. But I'm just saying they're not the most straightforward things to feed. They take a bit of looking after valve testers. And if you've got a valve tester that you think is reliable, then it's kind of worth its weight in gold. It's worth keeping hold of. So let's have a look at one of our other valves that we've bought, which is this next one is, I forgot what we did. What did we do there? We did the DL32 there, didn't we? So the next one we can do is we'll do the DL35. So let's just check what socket the DL35 should be in. It should be in socket 1 again, so that's okay. Socket 1, DL35, so switch A needs to be at 1. Okay, so switch A is the filament voltage, and so that's a 1 volt filament for this. Switch B should be at F position. Okay, so we'll do that. Switch D should be at 6, which it is. Switch D should be at E, which it is. And socket 1, and we're in socket 1, so we're good to go. Quite important that we get these settings. It's quite, again, sorry you can't see very well, but it is important that we get these settings correct, because if you get them wrong, particularly the filament one, you could have very easily burn out the valve. Now, I suspect we won't have to adjust this filament voltage for all these valves we're testing, because they're all 1.5 volt filaments, so it should work with any of them. We can leave it set to number 1 for A. Right, okay, so same thing again. First thing we test for is shorts. So let's press the short button, and the light doesn't flash here, so that's okay. We've got no shorts. Now we'll go for leakage, and again it's showing us good for leakage at the moment. And now we'll go to emission, and the needle's gone up into the good section here, into green. So we're good for emission there. So that measure's okay. Switch it off. Next valve is a 1HGT. Now I think I might have to cross-reference that to something. I don't think we're going to find that, but we'll have a go. In fact, that's probably, I was going to say, is that an American tube, a 1HGT? So I'm just thumbing through the valve data looking for something which has got the 1H prefix. And I'm not finding it. Can anybody on there cross-reference a 1H5 GT? 1H5 GT, anyone? Anybody cross-reference that? That's a 1H5 GT. Got a 1H5, but I'm not sure. A DAC32, right, okay. DAC32, I trust Simon, DAC32. I think Simon might have the same valve tester. I think you've got one of these as well, haven't you, Simon? Haven't you got one of these Mighty Mites? Okay, there we go. A DAC32. Thank you, Simon, if that's correct. DAC32. Now this is actually one of the valves which we already knew was good because I've written good on it. So this was the only valve that survived last time. It was the only valve that hadn't got a burnt out filament. So let's just see if it survives this. So it looks like it's got a couple of sections in it, this, because the tester's got two test settings. It's got the first setting says 1G6K1 and the next test is 1G6E1. So there's a K and an E. So what that's doing, it's testing different sections of the valves depending if the valve tester is set to K or E. So let's go 1G6K. So 1G6K and it's socket 1. Simon said he hasn't got this model. You have got a Senko though, haven't you? And it says in the notes here, disregard shorts. So it may be when we turn this on, it'll come up with a short lamp on it. It says disregard it. Well, nothing came up as shorts. Okay, nothing's coming up for leakage. Well, this one isn't showing any emission, so that setting isn't working for this. Let me just double check I've got it right. DAC32. One G 6K socket 1. We have. Let's try that again. Oh, top cap. Top cap. Did any of you, none of you shouted out, does it need the top cap? Is that what we're missing? Oh, and it sprung right over. Good. So I was missing my top cap connection. Silly me. And then to test the other section of the valve, because according to this, it must have 2 sections in it, we need 1G6E. 1G6E. And that's coming up with good emission as well. Let's catch up with the chat. Okay. Thanks, Doug. The 1H5GT, sorry, the 1H5GT, that's the double diode. That's the diode triode. So it's got 2 sections on it. It's recovering the audio from the IF, isn't it? It's our detector, if you like. No, thanks for the offer, Graham. It looks like our valve's good. So we've got a final valve to test here, which is our DF33. Which is this is a variable new RF amplifier that I talked about. So this is actually being used as an intermediate frequency amplifier in this set. So DF33 we're looking for. Yep, we have a DF33. It seems pretty good, this valve tester. It's actually managed most of the tubes that I play with. I've had it just over a year now. I've got to admit, I've not tested hundreds of tubes in it, but the few tubes of, all different flavors and varieties that I've tried in it, it has been able to test them all. So, yeah, I'm quite impressed with this little Mighty Mite. I would definitely recommend this as a tester. I would, unless you really need the mutual conductance meter, I would actually definitely recommend this over the Avo, because the Avo, it's just a total faff to set up. It's too many, it's got these setup controls ×5, and it's just a faff to use, even if it's a better piece of equipment. So if you're actually thinking of investing in a valve tester, the Mighty Mite from Senko gets the all the gear, no idea seal of approval. So if you can get one at reasonable cost, pick one up. If you need a valve tester, that is, and I'm telling you, you probably don't need one. So our final valve, DF33. So we need 1F 6K1, 6K, and socket 1. And it's a top cap valve, so we'll put that on and go for shorts. No short circuits. Let's look at grid leak. We've got no grid leak that I can see. Sorry, I'll move that up there. Whatever I do, I'm getting a reflection. I'm sorry, guys. There's nothing I can do. Oh, I think we got it there, didn't we? And go on for your valve bingo. Is it going to go into the good for emission? I would probably have a pound with you. It's going to be good. If we press the emission button, here we go. Oh, God, I've just lost £1 to you all. It actually comes up as in the question mark. So it's actually saying that this valve could be a little bit weak, or it's certainly not in the good section anyway. So that's our DF33. So yeah, so maybe we need a different DF33. That's the point where really you just want to go and get another valve out of stock and try it in the tester, because these testers, yeah, they're not a perfect tool, and they can be a little bit misleading, but they're kind of better than nothing. They can give you some confidence. So this is where I would like to, if I had one, maybe pop out to the garage, have a rummage through my valve collection to see if we've got another DF33, because maybe we've got one, but yeah, then again, maybe we haven't. So if this radio proves to be a little bit weak, you know, if it's not pulling in stations very strongly, then we might have to suspect this valve, because it's probably quite an important valve, this intermediate frequency amplifier. It needs to be good. So there was we had a little bit of a chat, my extremely non-expert guide to valve testers and valve testing there. I'm sure there's an awful lot more to it than what I've just said, and also a lot more complication, but like so many subjects, you can dip into these things as deep as you want to. This seems good enough for me. The only problem that I do have with this tester is, unfortunately, the American plugs, sorry, the English plugs are a lot bigger than the American ones. So unfortunately, you can't actually get the plug into it and shut the lid on it. It's just too big. I don't think you can anyway. Let me just have another go. Fairly sure you can't. No, so you've got to kind of arrange it so that the lead just pokes out the side, and I could probably do with cutting a hole or a slot in the side of it, but that would be a shame, wouldn't it? Okay, you've got to be careful because it's just crushing the lead slightly, but there we go. So there's the Senko TC154 tube checker. So I'll tell you what, we've cleared a bit of space on the bench. I just briefly need to go and powder my nose because I don't want my forehead shining too much on camera, and I'll be back when I've applied some more makeup. Okay, looking good. Right, let me just catch up with the chat. Oh, Graham says it's very muggy where he is, and the rain's coming. Yeah, it's been quite nice here this week, and apparently we've got heavy rain forecast for tomorrow, but it's good at the moment. Oh, thanks for the offer of the valve, Graham. Oh, so Simon says it's dull and cool where he is today. Okay, Simon's valve tester is he's got a 115 volt one. I think that the one that I've got was originally 115 volt, as they all were. I think that the chap, if you go on eBay and type in valve testers, there's a guy on there who specialises in valve testers, and he's always got 2 or 3 for sale. And I think he must import them from America and put the transformers in them, which is not really. Well, I don't think he replaces the transformer. I think he finds room inside it to put another transformer, because that's, as Graham Radio Cruncher will tell you, the transformers inside valve testers are very, very complicated affairs, because they've got all these various filament voltages and different anode voltages, which various valves operate from. So they're an absolute nightmare. They're like some kind of conjoined twins of mutant octopuses. A transformer out of a valve tester. They're a horrible thing. I know that Graham's got a valve tester. I don't know if he's got one like one of the ones that I've got. Oh, the model's gone out of my head. Hickok. I think he might have one of the more advanced Hiccup ones than I've got. Oh, okay, cut the pins down on the plug. Yeah, give that a thought. Yeah, Graham's got one of the Hiccup testers, I think, and his transformer blew up or didn't work. and he has had it rewound, and I think hopefully it will be ready to go back into the valve tester soon. But I think the problem with it, the chap who rewound it, he didn't make a note of what any of the windings were, and originally the valve tester had each of the windings was color coded, so he could have put it back into the correct order. Well, the new transformer with its new windings on, it's probably got all grey leads coming out of it or something like that. So it's not very easy to work out where any of the wiring goes. So he's got his work cut out for him there. So valve testers, yeah, they can be a real pain in the bum. If they're not working, they can be really fiddly, and the circuit diagrams for them tend to be horrendous. In that there's switch after switch after switch, lots of multiple banks of switches, and if you have problems with them switches, you're in a world of pain. So yeah, it's buyer beware. You be very careful when you're buying a valve tester. You either don't pay a lot of money for it, or you buy it from somebody you trust who's tested it properly. It's not the sort of thing you want to pay a lot of money for and then repent at your leisure. All right, okay, I'll blow kicks off to a barbecue tonight. I'll tell you what, if the weather holds good for tonight, I might have a barbecue as well. We bought one of these Smoky Joe barbecues, and because I think the leg fell off the other one, it had 2 legs, and now it's 3 legs, and now it's got 2, so it doesn't stand up anymore. So we bought a new barbecue. Yeah, I was going to say, what you're gluing your patch on your inflatable hot tub? Okay, inflatable hot tub lid. Yeah, you're telling me that's it's an inflatable something, but I'm not sure it's a hot tub lid. But we'll believe you. All right, I'm sure that most of you must be shouting, "Get on with it" by now, mustn't you? Okay, okay, you're all shouting, "Get on with it," so I guess I should. Now, normally, I would go ahead and change out some capacitors at the moment. First thing I would do is change out some capacitors. And I've got to admit, I am inclined to change out a couple of these before we put some power on this radio. Because battery sets, they're not as stressed as mains voltage sets. They work at 90 volts rather than 350 volts, and they're not as stressed. And so leakage, I'm going to go out on a limb and say that leakage isn't quite the problem it is with main sets. But looking at some of these capacitors, there's 2 in particular here, which are, well, they're waxy capacitors, obviously, but to me, the wax is all melted to one end, and they look bad. They're wet, sticky, and oily, and to me, that's a suspect. I was watching. I think it was. Oh, I always get his channel name, Vintage Electronics. I was watching Andy the other day, and he was talking about whether or not to change out capacitors or not. I'm doing a lot of talking today. I'm in a bit of a waffly mood. Bear with me. You can always do something more interesting. Go and watch the football if you're bored with me. So there's an ongoing debate, isn't there, about whether or not to change out capacitors. Some people say, don't change them out and diagnose them. Other people say change them out on site. I think my stance on it is it's silly to have either rule, to either change them out on site or to kind of never change them out and test them. You don't want to have your head stuck in the ground like that. The reality is pretty much most waxy capacitors that are 50, 60, 70 years old, they will be leaking. They will not be good. I promise you. You don't get a capacitor which is 70 years old, a waxy capacitor that isn't leaking. It will be leaky, I can promise you. The only difference will be is how badly it's leaking. Now, some positions in a circuit, it doesn't matter if there's a little bit of leakage, a bit of RF decoupling, who cares? The capacitor will work fine. But when it comes to things like grid coupling capacitors, really you want to change out the grid coupling capacitors on site, because you've got to remember that unlike transistors, valves are voltage operated devices. They don't work on current, they work on voltage. So if you've got any, and the impedance of a valve is very high, it's in the gigohms. So if you've got any leakage whatsoever on a valve, on a capacitor, any leakage going into that grid, it will increase the voltage on the grid. And if ever you put your grid positive on a valve, it will red plate the anode. So if you've got 350 volts on one side of a capacitor and 0 volts on the other, it doesn't take very much leakage to start to lift that that grid voltage up, because remember, you're going into something that's a gigohm. Probably the only impedance it sees is if you've got a grid leak resistor there or something like that. Very, very high impedance. So if you have any leakage at all, it's bad. And like I say, I can promise you we will have some leakage on here. So I'm not exactly sure what these capacitors are. I've actually got the data sheets. So let me see if I can hold it up to the camera. It's basically that capacitor there is gooey and horrible, and the other capacitor at this end. So I'll just point that again. So that capacitor, the bigger one, all the wax has sagged and gone to one end, and then there's another capacitor here where most of the wax kind of appears to have boiled off it, and it's all in big blobs on the side of it. Now that could just be because this radio has been stored up against a radiator. It could be something else which is making the capacitor looks bad. But to me, these two capacitors look bad. I know that one of these, I believe, is a grid coupling capacitor, and that's a good reason to change it. And I think, again, because we're in waffle mode, we'll probably go ahead and test it as well. So that's a 0.05 microfarad. Let me just see if I can work out which one that one is. So for those playing along at home, I was going to say it's either C15 or C17. According to that, it's actually C15, but this is drawn wrong because, yeah, okay, let's see what's C15. So C15 is an AF coupling capacitor. Oh, wait a minute. I know I'm looking at the wrong capacitor there. Bear with me, bear with me. God, it's absolutely filthy. Yeah, okay. Okay, well, we've spotted something. We've got something wrong in our circuit diagram here, in that it says that this one is C15, which is the AF coupling capacitor, which it says is 5 nanofarad, whereas actually the capacitor that is in there is 50 nanofarad. It looks like the circuit diagram has got two of these capacitors. They've got them in the wrong way around on the drawing. They've got C15 and C17 mixed up. So I'm fairly sure that the bigger capacitor here, the one that is 0.05 microfarad, I think that is that's the grid coupling capacitor. So that is that's feeding from the output from the that's feeding the output from valve 3, which is the triode stage of the detector, and it's feeding into an AF. Yeah, that's the AF coupling capacitor, C15. Oh no, wait a minute, wrong again. It's so dirty, it's difficult to read them. C15, see what's C17. C17 is also an AF coupling capacitor. Okay, so basically the circuit diagram's wrong. I'm going to assume the circuit is right. If you look at the circuit diagram, these two capacitors, they're shown the wrong way around in the actual diagram. Just change them, yeah, save time overall, yeah. Yeah, well, I agree. You know, that's generally, I mean, talking about these capacitors, Graham said just change them, it saves time in the long term. I certainly wouldn't argue against that position because you just know that they are going to be bad. But in some positions, it won't make any difference. That's all I'm saying. Depending on what position it in, it won't make any difference. Now, I do things like bother to measure the leakage of them. But to be honest, it's almost pointless measuring the leakage because all you can say is you know they're going to be leaking. You know, there's no if about it. They will be leaking. So you may as well just get on and change it. I'm just trying to work out why these are the wrong way around on the diagram, but I'm pretty sure that whoever drew the diagram, unless I've got the radio, have I got it the wrong way up? Maybe that's what mistake I'm making. What, am I looking at it the wrong way up? C17. Okay, that was maybe the mistake I was making at it. A bit of a newbie error, looking at it like that when of course it's drawn from the bottom. Oops. What a silly fool. All's fair in love and radio repair though. So pretty much all the wax has actually come off this capacitors already. It's all just, it's run down them and it's all just sitting there in a pile at the bottom. So we'll have that out. And we will play some capacitor leakage bingo, I think. So let's snip that one out. So that is 0.05 microfarads. So that's 50 nanofarads, isn't it? Let me just check on the chat. Actually, Simon's saying don't trust this serviceman. No, I think the rule here is, Simon, never trust me because I'm an idiot. That's actually the rule. Don't trust me because if I can get it wrong, I generally do. Oh, the radio shop's joined us. Good morning. Thanks very much for joining us today. I'm a big fan of the channel. Yeah, Simon's saying that some of the wax capacitors never actually see any DC. No, I mean quite right. But again, it depends if you're doing. Depends what sort of restoration you're doing, doesn't it? If this was, I mean, I don't do work for customers, but I kind of take the point. If you're restoring a radio from a customer, for somebody who's paying for work to be done, you would probably want to change out as many of the bad waxy capacitors as possible because you don't want them coming back to you in a month's time. Because that's the thing about radios. Somebody will bring you a radio and it's been asleep in a garage for 70 years or in a loft. And you plug it in, and as an engineer, it's only on your bench a few hours, isn't it? Whereas when that person takes that radio home with it and he starts using it for weeks, well, days and weeks and maybe months, that's when the faults are going to show up. They're not necessarily going to show up when they're on your bench there. So, yeah, I think that if it was like a customer set, I'd be inclined to be changing out all the waxy capacitors. But I'm going to do something pointless. I'm going to measure the leakage. It's probably going to prove me wrong again. So I was also just going to make a point of saying that I've got a couple of insulation resistance meters, because again, I think Andy was saying on his channel that he doesn't have a leakage tester. Again, comes back to my need to purchase more and more test gear. That's where the channel name comes from. I've got all the gear, but I've got no idea how to use it. So we just buy more and more test equipment. Don't ask me why I buy test equipment. It's just one of my dirty secrets. It's a fetish thing. So I've got all this test gear which I don't know how to use. And amongst that test gear, we've got this Avo tester, which was my first mega meter, which I used to use this when I did industrial installations. So this is a good meter. It's got made by Avo, so it's good quality, and it's got a 500 volt setting on it, and it's got a 1 kilovolt setting. And these to buy are, I think you can probably still buy a very similar model, and they are, you know, they're relatively expensive bits of kit to buy. But more recently, these have come onto the market. So this is a Sanyo VC60B Plus, and I can't remember what these are. I'm going to go for they're about £60. They're not ridiculously expensive, and the reason I actually like these is this one I've had for a couple of years. It seems to be reasonably reliable, certainly good enough. But whereas the Avo has only got a 500 volt setting on it, this has got, it's got 250, 500 and 1000. So sorry, the Avo has 500 and 1000, but it doesn't have a 250 volt setting. So there is a lot of capacitors that are rated at 250 volts. So you can't test them with the more expensive Avo meter, but this little cheap Chinese meter does do the job. So I think it's worth the money. They're not very expensive. So let's see if I can get an electric shock off this. I usually will. Well, of course, then we can argue about which way round to put the capacitors in. So let's argue about that later as well, remind me. So, okay, all's fair in capacitor bingo, isn't it? So let's plug the meter in. Let's see what leakage we've got. So put it onto the 250. We'll go for 250 volts first. This is a 500 volt capacitor. Okay. That's measuring 1 megohm. That is just 0.9 megohm. So that's at 250 volts. Let's try it at 500. Okay, it's measuring 0.8. So that is just crap. So this is what I'm saying, that as a grid coupling capacitor, it was a total waste of time to measure this or even debate whether or not to change it out. They just need changing. Just change them. Don't even think about it. Just change them. Is anybody violently disagreeing there? No, Simon's right. No, I've got no idea, Simon. I've got no idea what I do. I just make it up as well, and I'm just winging it blatantly. If Scott's saying you almost bought one the other day, yeah, I actually would give these my vote of recommendation. I think you can buy them on Amazon, and I know you do some of the Amazon merchandising thing on YouTube, so that might be a good thing to have in your YouTube shop. They get my recommendation. I think they're very good for the money. Yeah, we all just try and make it look like we know what we're doing. Okay, sorry, I forgot the name of the chap at the radio shop. I'm sorry, I've forgotten your name. I do watch your channel a lot, but your name's been out of my head. But thanks for stopping by. It's much appreciated. Brett says changing caps is relaxing. Yeah, it is kind of relaxing. It's a low-hanging fruit, isn't it? Average Joe says he's restored lots of clocks. I've taken apart lots of clocks. I don't think I've ever succeeded in putting one back together though, Sam. Yeah, Simon said he's got an old analog mega meter. Yeah, of course, the original meters were called mega, weren't they? I think that's why people call them megameters, or that's why people used to refer to them as megas. But mega was, you know, it was like Hoover. It was kind of a trade name, wasn't it? Oh, it's Buddy. Of course it is, Buddy. Sorry about that. I totally forgot your name, Buddy. No, you haven't missed anything at all, Benji. Benji says I've missed anything. No, you've missed nothing, just me waffling on about nothing as usual. So here's the first capacitor that we knew it was going to be bad, and in fact it was. So let me get this one changed. And I think what we might do is, I don't like to keep you here all afternoon because I'm sure you've all got more interesting things to do than watch me. What we'll do is we'll probably just change out the AF coupling capacitors because they're the ones that do the damage, and they're the ones that are going to red plate our valves. Not that it's such a problem with battery sets, because you know the batteries don't have enough current behind them to do the damage. So what do I need there? So I said I needed 0.05. And I did actually get some capacitors out early. Which is 47 nanofarads. I think what I'll do is, again, just for expediency, I'm just going to tack these in for now. And what I will do is, off camera, I will do a nicer job of it, assuming it works. Because that is generally the way I like to work. I don't like to invest too much time in a set. You know, this hasn't been powered up yet, so we just want to see that it's got some signs of life before we do too much work on it. So we'll tack these in, and off camera we will go back and tidy it up a bit later. And it's getting good capacitors as well. It's getting the 600 volt ones, the Vishay. That's a Vishay anyway. Only the best. Okay, so I think there's another audio coupling one. I think we'll do the tone corrector cap while we're at it. I suppose we should probably do them all, shouldn't we? Okay, there's another one. Let's see what that one is. 0.05. Let me just... C2. What is C2? C2 is a decoupling cap. I think we can probably leave that for now. Yeah, we won't change that out. Where's the... There is another... I think we'll change this 005 out, which I think is another grid coupling capacitor. We'll have that out. C15. Got a memory like a sieve. What was C15? Yeah, C15, it is AF coupling, so we'll have him out because he's one that is likely to fail. Right, and we'll have another round of capacitor bingo. So here we've got, oh, it's even a higher volt. So this one's 1,000 volt working. It's 1,000 volt rated, and it's 5 nanofarad, which is 0.005. So let's get the meter ready. Scott, go to bed. It's too late. Probably got work in the morning. Go on, go to bed. Right, okay, we've got the capacitor lined up. Can you see everything? Okay, so at 200 volts, 250 volts, it's measuring 5 meg. Let me just hold that button down. Let's try it at 500 volts. 500 volts, it's measuring 3 meg. And for some, well, it's actually, that's one thing about these meters. On the 1000 volts range, if you pull too much current, they don't seem to like it very much. So this is actually just, although it says 7 on there, it's actually measuring short circuit, that. So yeah, that's another bad one. So yeah, no good. Oh, I didn't actually check either of these for capacitance, did I though? I know some of you do like to play capacitance bingo, so shall we check them for capacitance as well? Probably a bit pointless, but go on then, let's just do it. So this one should be 5 nanofarads. Okay, not terribly bad, is it? 7.4, so it's gone a bit high. You see that? Don't know. Yeah, so that's a bit high. 7.4, it should be 5. It's not ridiculous, so is it? And the next one should be 50 nanofarads. Oh, well, you're going to have to trust me because the lead's coming off. That's actually measuring, believe it or not, 49 nanofarads, 49.9, and it should be 50. So after 70 years, you can't get much better than that. But it kind of goes to show you that you can measure the capacitance, and the you know, it's not the capacitance that causes you the problem. The capacitance is good, measures good, but they're leaking really badly. Oh, I'm covered in smegma now. Get this off my hands. Just check up on the chat. Oh, Benji's making some lampshades. That sounds very artistic. Lots of sticky back plastic and Evo stick. I suspect Benji's probably one of the people who used to make the Blue Peter Advent crown as well. Have you made any of them recently, Benji? The ones with all the tinsel and the fire hazard? Remember them? So remember the Blue Peter? I think it was called. Wasn't it called the Advent crown? It was basically just child slaughter with tinsel. Yeah. It makes me wonder how many houses actually burnt down with those things, or perhaps people were just a bit more careful back in the day. Yeah, hold on to the wires. Yeah, just hold it. It's the apprentice trick, that, isn't it? Hold on to the wires. Yeah. Yeah, wipe it on the curtains. Yeah, I've done that before. Wiped it on the curtains and made a sharp exit. Yeah. Yeah. It's not contact cleaner, I'll have you know. It's IPA. Right, okay, let's get that one on. Obviously, it makes all the difference, IPA. Well, I'll tell you what, they're quite happy to splash it on you when you have your vaccinations and things, aren't they? A little swab of IPA. So if I spray some on my hands now, it's not the end of the world, is it? So we need a 0.005. Well, of course, we're going to put a 0.0047 in because that's the nearest we've got. And although it's a brand new capacitor, it's probably still a good idea to check them, because even brand new components fail. Yep, 4.8 nanofarads. Close enough. Just struggling to solder this terminal. It's just so dirty. I think I've got it there. Might not be a great joint. Again, just, oh. And of course I pulled it off. Oops. Okay, so we just put that in temperature. Now the other one I want to change out is another capacitor, which again I think you should change them out, is the tone corrector, which is wired across the speaker. Now the reason you should change out a tone corrector capacitor is because sorry, it's not wired across the speaker. It's wired across the primary of the audio output transformer. So the tone corrector, I think another word is a Zobel capacitor. The reason you want to change those out is because they tend to be quite highly stressed. Although the voltage across them might only be 90 volts, the fact that the output transformer, the audio output transformer, it's an inductive load. So when your output valve is pumping the bass, it's effectively putting pulses of current through an inductor, which is the primary of the audio output transformer. And of course, lots of you who've played with things like relay coils, you will have seen that a relay coil has a diode across it, doesn't it? And that's to prevent damage to the driving transistors from the back EMF from the coil. Well, you also get a back EMF from audio output transformers as well, from the primary. So those transistors tend to be quite highly stressed. And so that's a good reason to change them out. So I'm just looking for that in here, which is the tone corrector, which is, I think that's C18 on here. Let me just have a look. C18 tone corrector, but where is C18? Okay, that's that one there. It's another 0.05, so we'll have the tone corrector out. Because these capacitors are highly stressed in operation. Does anybody disagree out of interest? I'm quite happy if, well, have you come here for the 5 minutes or the 10-minute argument? you don't have to agree with me, by the way. I'm quite happy for you to argue over these comments in the chat. Go for it. Right, okay, so we've pulled the 0.005 out. Let's just check it again. Let's measure it for capacitance first. So we're looking for about 5 nanofarads. Probably will be. Okay, and it's coming up 7 nanofarads, so it should be 5. It's coming up 7. There's nothing wrong with that, is there? But for leakage, I suspect we will be leaking quite badly. Now, the reason that leakage is bad on these particular capacitors is because the leakage usually, it doesn't actually cause, well, start again. It's because they'll probably fail short circuit at some point. They're a highly stressed part, and that's why we're changing them out. Okay, so that's bouncing around quite a lot. Let's try it at 250. Let's try it at 500. All right, okay, at 500 it's settled down. It's reading 1.8 meg. And I think 6 meg on the 1000-volt scale. I suppose what I should have done really is showing you what a good capacitor looks like. So let me find one. Which one was I going to put in there? Can't read that. Old eyes. It's true what my gran said. I did go blind. So it's not that one. Oh, looks like I need a different capacitor. I'll have to go in search of a capacitor. So we need 0.005. Okay, here's a 0047, and just for comparison, let's check this one for leakage. What's the rating on this? This is 630 volt rated cap. So we're only going to test this up to 500 volts rather than 1000. So at 500 volts, just to show you, that's the infinity reading on this. So this is showing absolutely no resistance. It's a perfect insulator. That's infinity. And that's really what capacitors should read. They should be reading infinity. And that's probably going to have some voltage across it now. There we go, discharge that. Just catch up on the chat. Oh, charging cap. Yeah, I used to like charging capacitors up and leaving them on the bench at work for somebody to discover. Yeah. Save the wax. Yeah, I've got bees. I don't need the wax. Oh, Andrew's come for the full 10-minute argument. Well, I've told you once. Hi, Andrew. Paul says, no, you wouldn't. Yeah. Victor says all the wax capacitors need to go. Oh, and Benji's going to drown a tea bag. Oh, God. Simon's de-waxing his chest hair. That's a lovely thought, that. Right, okay. Let's solder these in again temporarily. After all this, it probably won't work, will it? So that'll be another live stream next week when it doesn't work. Right, got that in. Right, the other waxy capacitor is looking a little bit waxy, and I will come back and change it later. But the reason I'm not changing it now is because it won't actually cause any damage to the valves if it's bad. It'll need changing out, but I'm not going to do it this second. Now, I've also just spotted, so this has got a replacement RS branded capacitor on it. Now, these tend to be bad in my experience, these grey coloured RS capacitors. I think these came out in the 1970s. Now, this is rated 2 microfarads at 500 volts. It might be okay, but in my experiences, they generally go bad. So, tell you what, we'll leave that in. I will change this out off camera. I think just for the point of view of moving things on a little bit, I think it's time to maybe put some valves in and think about putting some power on this radio. Does everybody agree? I'm going to take that as a yes. So we've just have a bit of a tidy up. We've done with the insulation resistance tester for now. Don't think we need any solder, so turn that off. So time to put some valves in. So our first valve is V1, which is the DK32. So let's find that. DK32. And I'm going to spray a little bit of a contact cleaner to help this valve go in. They're quite tight, these sockets, and I'm sure a bit of cleaner might just help things generally. Oh, I'll tell you what I wanted to do is I wanted to actually put these valves in with the heater supplies on, didn't I? Because last time we were getting no heater current. Can you see my bench power supply up there, about up you a bit? Can you see that? Okay. So we should have, in fact, we'll take that valve off. Should we take that valve? Take that valve out again. Be careful, just walking it out. You can quite easily break the bases on these. It's quite a tight fit, that. Okay. So I'm going to connect up the my benchtop power supply. My benchtop power supply is set to 1.5 volts, more or less. And I think we were on the chassis, which is black, so I think we can put one of the leads directly onto the chassis, and we can put the other positive lead for our valve filament here. That goes onto the blue wire in this case. So we're now supplying filament voltage 1.5 volts to our heaters. I can see on my current meter up there. Oops. Get out. You want to be famous, don't you? Fighting with it. Okay, so can you see the current meter up there? I realise you can't see it very well. I'll read it out for you. So basically that's 0 milliamps at the moment. So let's stick this valve in and hopefully we should see some current. Okay, I've just stuck the valve in and that's showing now 51 milliamps. So this valve is consuming filament current. So that's a good sign. So that's V1, our DK32, which is our frequency changer. So what's our next valve? V2 DF33. DF33, that's that one. Again, put a little bit of deoxit on. Oh, actually, that was IPA, wasn't it? Deoxit instead. Just wetting the pins with it, basically. This is V2, which is our DF33. And now that's drawing 100 milliamps, so that's good. That's drawing more current, so we've gone from 50 to 100. I have got the right valve in there. I've got a DF33 is valve 2, isn't it? V2 DF33, yeah, got that right. Next valve is V3, which is our DAG32. Now, I didn't have one of them. That was the one that had the different number on it. I can't remember which way around that is. So what's V4? V4 is DL35. Have I got them the right way around? Which way around do these valves go? V3. That's that one, okay. Had a bit of a brain fart moment there. This valve has got different it's got a different numbering on it. This is our 1H5GT, which is a standing for the DL35, which is obviously a different tube. Right, got that in. So finally, our final tube is, oh, no, I said that wrong, didn't I? Let me just think about that. It has to be the right valve because that's the top cap valve. So that's V3. Okay, it was a change for a DAC32, DAC32. Okay, I think I've got that right. I'm just going to double check myself because I've got the other valves here. In fact, I'll just put that valve in finally. Okay, so we're drawing 150 milliamps now, so that sounds about right. So this should bring us closer to 200 milliamps. $250 milliamps. Okay, so looks like we've got a full complement of heaters all warming up nicely. Not that they do warm up. I'm just going to double check these old valves that I took out because I wrote the valve numbers on them. So let me just check. So V2 was a DF33, which it is. Okay. Yeah, I think I've got them valves in right. Just had a bit of a moment, bit of a senior moment there. Let me just catch up on the chat. Tubes or valves? Yeah, good question. Servicol or deoxit? I think deoxit is very expensive, but is it any better than Servicol? I'm not sure it is any better, but it's kind of the thing that a kind of deoxit probably lasts me 2 or 3 years, even though it's like 30 quid a can or something daft like that. You kind of think about it's your main hobby and you're spending £10 a year on deoxit. It's kind of affordable, even though it is kind of got to sell your kidneys when you buy a can, haven't you? But yeah, whether deoxit is better than Servicol, I don't know. Doug says he prefers deoxit. Okay, yeah. Ah, hi Tony, nice to see you. Yeah, this is a battery radio. Yeah, 250 milliamps. So that 250 milliamps, Tony, that's just for the filament. So that's not actually the voltage which is really operating the. It's not the high tension supply. That's just to heat up the valves. So you've got to provide 250 milliamps of current to this thing, just to actually. Just to heat up the valve filaments, and then you need the HT battery to actually power the radio. It makes me wonder. I wonder how long this valve portable would have lasted on its original battery. I wonder what the amp hours were of the original battery. I don't know if it tells you what battery it used in this data sheet. I've got a feeling it might do. No, I'm not sure what battery this did take. It says that early models used a combined HT and LT battery, but later ones used a separate HT and LT units. So, and probably what was happening there is that the low tension batteries, the filament batteries, were probably going flat. So people were having to replace the whole battery in the set, the high voltage section as well as the low voltage section, and probably getting annoyed about that. So what the makers did in later sets, they made the high voltage batteries and the low voltage batteries. They made them two separate batteries, so you only needed to change out the one that had actually failed. Yeah, I wonder how big the original batteries were. I've got no idea. Right, okay, so that's the valves in place. What we need now is that was the low tension batteries. We need some high tension. Manny, I'm sure you're all believing. I'm sure we've had enough tension, haven't we? This whole episode has been high tension. So here's Mr. High Voltage Power Supply. Say hello.
Hello.
And the high voltage power supply that I'm using today is a Heath kit. Okay, I'm just looking for some test leads which will go on here. And failing to find some test leads. Just bear with me, boys and girls. We just need to find some test leads to feed in the high tension supply. Okay, unfortunately, we haven't got any decent wire colours. Just going to set this to about 90 volts. So remember, green is going to go to our yellow, so that's the 0 volts for the high tension supply. I don't know why I'm telling you this. It won't make any, not useful information for you guys, is it? And I don't have a red wire on there, so it's going to have to be blue, because obviously that makes sense. Not at all. And the blue wire is our plus 90 volts, and that has to go to red on here. Oh, and I heard a little crackle come out of the speaker there. But of course, the other thing we need to connect is our frame aerial, which, oh, I can move you back down again. So we've got a frame aerial that we need to connect up. So, yeah, how can we get that into circuit? Here's a frame aerial. So our frame aerial's actually got 2 windings on it. It's got one with two sets of windings. One has got many more turns on it than the other. So I think the one with a few turns on it is a long wave tuned antenna, and I think the one with lots of turns is probably the medium wave antenna. So you might be wanting to start to place your bets. Is this going to work or not? I've got no idea. So these wires are color coded. We've got green, blue and yellow wires to put on. So I've started off by putting the wrong wire on. That's a good start. It's quite difficult to tell the green and blue wires apart because the colour's faded on them. So that's the green. The green and blue look very similar to each other, I'm afraid. Oh, Anonymous Repair. Hi, how are you doing? Thanks for joining us there. Okay, last one, yellow wire. Now, of course, we've got no idea if this radio is going to do anything, and I've got to admit, whether it works or not in today's session, this is probably where I'm going to leave it, simply because I I've got another appointment just after 4, so I'm afraid we're running out of time for today. We are somewhat against the clock, but I think we've been going for 2 hours, and I think that's long enough, isn't it? I'm sure you've all got more interesting things to do on a Saturday. And Scott definitely needs to go to bed if he hasn't done already. Not going to be the easiest thing to fault find on this because, well, because it's all wibbly wobbly and everything's flopping around. And like I say, this external frame aerial, which has to be plugged in because it's a resonant antenna system, it's actually used as part of the tuned circuitry. So you can't just stick a wire onto here and make the radio work. It needs this tuning frame aerial antenna. So, okay, have we got any power on at the moment? No, let's turn the power on. Is it going to work? I've got no idea. I can hear a little bit of hiss.
TV's coverage last night.
We are working.